Hi viewers, in this video we are going to be looking at quantitative or rather qualitative analysis. Qualitative analysis. Qualitative analysis. Okay, that is identification of ions. So in this video, the two inorganic salts is lead 2 nitrates and sodium carbonates. Okay, in this video, I'm going to be explaining this practical under 3 categories. The first category will be a kind of a theory background, and then we do the practical. We have our reagents, the setup, and the step-by-step how the chemical reaction as far as identification of these salts is concerned. And then the last will be how to take down your reports from the experiment. So the first is going to be the theoretical parts. What we explain in this first stage will take us to the practicals and then the report. Okay, those are they will be writing SSC. Be very they should pay attention to this class and then to know what they require to do, most especially SSC, NECO, WAEC, and even IGCSE candidates. Okay, this piece of information will be very important. Okay, now let's start with the salt itself. The salt is lead 2 carbonates, lead 2 nitrates and sodium carbonate. These are their common name. Okay, the IUPAC name is lead 2 trioxonitrate 5, and then here is sodium trioxocarbonate 4. The two salts are soluble. There are two soluble salts. That means these two salts are soluble based on the rule of solubility, that all nitrate salts are soluble in water with no exception, and also based on the rule that all sodium salts are soluble in water with also not exception. So that is a basic thing you should need to know as far as this salt is concerned. And then secondly, when you are carrying out experiments of this type, just like any other qualitative test, I think the student or the researcher should know this, that there is what we call preliminary investigation or preliminary test. Okay, this is a test you carry out. We can not call it actually a test. It's something that is observable feature, what you observe. As you can see in this video, look at the sample salts. That's the mixture of the two salts, the lead nitrates and the sodium carbonate. This is how the salt appear. Both are crystalline salts, and their color, they are all white colored salts. So with this piece of information, I can now know, I just know that there are things, there are cations that are possibly here, and there are cations that are not here. At least I can conclude now that there is no transition metal ion in this salt sample. Even if I'm not seeing the salt, maybe I have no idea that the sample is this. Maybe examiner will always put this to candidates as sample C. Okay, so you don't have any idea of what this salt is all about. So, but the first thing you will do is to observe the salt. Check if the salt is powdered. Check if the salt is crystalline. Yes, these two salts are crystalline salts, and again, the color of the two salts are white. Even though one is more appear to be more white, but the facts remain that the both salts are white, meaning that there is no transition metal ion in this salt. So that means we are not going to be testing for copper 2 in this video. no ion 2, no ion 3, no other transition or D block cation that is in here. So now I'm now going to narrow my suspicion to which cations are possibly here. Yes, one can even start to suspect. Suppose you don't have the idea that this salt is this, you have the salt given as C. So one can start to contemplate that there could be possibility that this salt could contain a metal of group 1, maybe sodium or potassium, metal of group 2, maybe calcium or magnesium, metal of group 3, that is aluminium, and some metal of group 4, maybe lead, and even possibility that this could also be zinc, even though zinc is a D block element but does not show that transitional property, being that this subshell is completely filled. So these are the cations. Before this test starts, these are the cations I should be suspecting to be in this sample salt. So that is on that note. Take note of that. Then the next thing again you must do, so which is also going to be under solubility rule. Solubility is to know the extent to which the salts can dissolve in water, the extent to which the salts dissolve in water, the extent to which the salt dissolve in water. Like I said in this video, before I start the practical aspect of this, I would like to do the theoretical part of it. So I think this is the test tube. It is here, okay, and just still allowing it to dry up. Okay, this is a test tube, or it could be boiling tube or even the beaker, and I'm going to take a very small sample from here, very small sample from here. Okay, this small sample here is these two salts, so I can just label these two salts like this. One is lead nitrates, okay, lead nitrates, and the other one is sodium carbonates. Okay, just like this. This is what I have in here. So I'm already taking some small sample of this and then transfer it here. Okay, the next is to know the solubility, the extent to which this is soluble in water. So maybe I'll measure from my measuring cylinder, maybe 5 cm or 10 cm of water. So I'm going to pour it in here. So as I pour it in here, then let's say this is the level of 5 cm poured in here. So the moment I pour, I need to shake, okay, to ensure homogeneity here. So as I shake, some part of this will dissolve. Some part of this dissolve. Let me say that these are the part that dissolve. Some part, let's say half of the salt, since it's in the same ratio, half of the salt had already dissolved here. So this is dissolved parts. Dissolved portion. And we're going to find out what portion just dissolved. Then this is the undissolved portion. Undissolved portion. Okay, let's see what is going to be there. As soon as this reaction happens, as soon as the water goes in, there is a double decomposition reaction. Okay, let's see how it happens. This is how it's going to be. This is giving me lead 2 ion. From here we have NO3 ion here. Okay, this one we have sodium ion and then carbonate ion. Then this is a double decomposition, is when you have two soluble salts and they react by exchange of ions. So you see this. So what you now have as portion that are dissolved is this area, this region had dissolved. So if you bring these two together, the dissolved portion is NaNO3. So the salt is no longer NaCU3 now. In the solution it is now NaNO3. Okay, which being that it dissolved, it is going to be in aqueous state. Okay, so that is it. So that is the part that are dissolved. So the part that is not that have not dissolved is this part. It is this part in connection with this part. Okay, so together this will turn out to be CaCO3. Just like this is aqueous, this is not soluble. All carbonate salt are not soluble in water, so this is going to be. So that is why the parts that is not dissolved. This is no longer lead nitrates, but lead carbonate. as soon as this is done, okay, the cation we're going to identify from the undissolved part, okay, which in this video we're going to be referring to it as residue because we're going to carry out filtration. That is what will be practical aspect of it. Will carry out filtration on it. So this is the part that we're going to be looking at. This is lead-2 ion, and this is carbonate ion. Okay, these are the parts we have, the residue part of it. So as soon as we have this, so we have, that means we have to separate these two from this mixture. So we use filtration process. In this video I'm also going to show you filtration process, how to separate this one out from the mixture. So we've got this as residue, and then we'll start to work on the residue. We'll have to identify if the ions in here is really lead-2 and as well as carbonate. Now if we are dealing with lead-2, we need something that can dissolve these two. Okay, when they are together, maybe I have lead carbonate as my residue, that is PbC3 as my residue. You know it is not soluble, so upon its insolubility, it's not soluble in water, so you now have to now check if it will be soluble in this acid, or if it is soluble, it will be soluble in this acid, or soluble in this acid. You have to choose which acid that dissolve this lead carbonate. Let's start with HCl. Can HCl dissolve lead carbonate? Actually, it can't dissolve lead carbonate. Let's see why it can't dissolve lead carbonate. If you add HCl to this cation, okay, now you have something like this, Cl minus H plus. So lead is going to act with the anion of this, then comes out as a precipitate. So this precipitate, it comes out as is not soluble, so it cannot dissolve. This acid can't dissolve this. The same thing with this acid H2SO4, which if you have SO4 2 minus H plus. So which of this is going to combine with this lead? I think this. So we have PbSO4. Of course, you know that lead sulfate is not also soluble, so this acid cannot dissolve it. So, but if we try this other, the last acid HNO3, and then we have and then we have hydrogen ion, NO3 ion. For possibly these two will go together, and we have lead nitrate. Okay, coming back to what we have, the soda we are giving. So this is soluble. So that means the acid that will dissolve the residue, which is lead carbonate, is HNO3. So what we're going to do on that note is to dissolve that residue by adding few cmq of HNO3. Let's see. If you add few cmq of HNO3, we have this plus, remember it is not soluble, plus HNO3. The moment this thing happens, the whole residue dissolves as lead nitrate comes out. What else is popping up? Water is popping up. That is H2 here, pick 1 O here. What is remaining now? A gas in that process is involved. But what we do, as soon as this gas is involved, you trap the gas and see if the gas is carbon dioxide. Yes, you test the gas to see if it's carbon dioxide. Maybe you pass the gas over lime water to see if it's return lime water, which is aqueous calcium hydroxide, which is colorless to milkiness. That confirms that the gas given off is CO2. In that same test tube, because as soon as we filter the filtrates, we keep the filtrate, and then we will start work immediately on the residue. So the residue is transferred back from the filter paper. It's transferred back to a clean test tube. You know it is solid. So the moment you add dilute HNO3, it starts to dissolve all of this. You know it's white initially. It starts to dissolve it. The next thing you now see a clear solution. So that means all of this had already dissolved. You see a clear solution. That clear solution is lead nitrates, PbNO3, lead nitrate. Then this gas is gone, and there is the remain of this, or that may be negligible. So the next thing you now do is, okay, since this nitrate, we cannot actually test for this nitrate here, we're going to try to test it in our filtrate. That is a brown ring formation. You use this salt, not this salt. So what we are going to do here is to identify lead immediately from this solution. So you identify lead in three steps. That means we're going to divide this solution here we have here into three portions. Let's say this one is first portion, this one is second portion, this one is third portion. Both of them contains lead. Now to the first portion, we have that lead ion. We are identifying this plus sodium hydroxide. This is actually coming from sodium hydroxide's aqueous solution. So a precipitate is formed immediately because of formation of lead to hydroxide, which is insoluble. So what is the color of this precipitate? It is white chalky precipitate. Okay, this is what actually happens in dropwise precipitate. That is what happened in dropwise. Okay, but until when you now add excess of this reagent, if this goes in excess, okay, because this is an amphoteric, this dissolves. So that means the precipitate dissolves, or the precipitate becomes soluble in excess of the reagent. Now the dropwise addition of sodium hydroxide to the first portion can also identify, because since you are kind of curious to know what ion, so that means sodium lead to hydroxide is not the only cation that can give white precipitate with sodium hydroxide. So other cations that can give white precipitate or chalky is calcium ion. At least these two are known for giving chalky precipitates. Okay, you can add aluminium if you like in this video, but I don't think you can add zinc, because zinc hydroxide more often is more like a gel-like form, so gelatinous precipitate. So these are the two at this point where you added drop of this. You have to put this. But in my last class in this video, I'm going to explain the table how this will be reported most often at the what you report, the column of inference. Okay, that is what you do with first portion. The second portion also, zooming, you will having this 4 cation. That is why you should go to the next portion to know. That means you now have this you are suspecting, okay, to be the salt. You are not too sure, so you go check out the second portion. Maybe the second portion this time you are using aqueous ammonia. Yes, with aqueous ammonia, the same thing will happen. With aqueous ammonia, white precipitates or the chalky precipitates will still occur. You're going to see it in the experiment. As soon as you see white precipitate in drop, what happened in excess? In excess, white precipitate will still persist, being that calcium is no longer here at this point. Why? Because the time we added excess of this reagent, sodium hydroxide, the precipitate form, the dissolution of precipitate suggests that the calcium ion is not in the solution. So we are now left with these 3 to go. So that 3 is what you are now going to now check when you now add ammonia solution to the second portion of the same solution. So what you now do now, upon adding it, the same white chalky PPT will come up in drops. Then in excess, white precipitate will still persist. Persistence of that white precipitate shows that they could be these 2 cations, since they don't form complexes with ammonia. Okay, they don't have interstitial property to form bond with ammonia. So that's why they are not dissolving in excess of ammonia. Okay, they can't form that ligand compound just like zinc will do found. So with that position now, it does mean that zinc is far away from being the ion that you are looking at in the salt. So at that point, you eliminate zinc, and then these 2 will now be going head to head at the point of the second portion. You are still yet to know which is who. Okay, so in excess, it will still remain, it will still persist. That means you eliminate this, you keep these 2, we're going. Then to the last portion, of course, the last portion is now to confirm the cation, whether it is aluminium or lead. Now there are 2 solutions in this video. We're going to use HCl, but we're not going to warm since there is no warming apparatus here. But I'm just going to explain to you what would happen on warming. So we're going to use HCl to the last portion, HCl with the last portion. This is HCl from the last portion. Okay, this is going to be lead chloride. Okay, lead 2 chloride is insoluble. So if you add HCl dilute to this last solution there, you see a white precipitate of lead 2 chloride, a white PPT. But if the cation is aluminium, upon adding this, there won't be PPT because aluminum chloride is soluble. So the precipitate form shows that aluminum is absent, then lead 2 is present. Now what you will do, lead 2 chloride somehow is soluble in hot water. What you will do, as soon as you add HCl, you observe white PPT, you warm the immediate solution. You warm. Upon warming, the precipitate solubilize, the precipitate becomes soluble. Okay, and then you may be asked to allow it to cool. Then upon cooling, the precipitates will return, will reappear back. That's confirmed that the cation in this sample is lead. Okay, that is on that aspect of residue. Then coming over to the filtrates now. The only test you're going to carry out in this portion of the filtrate is this one. There is no test, no one is going to ask you to test for sodium here. So we're going to run tests for NO3 minus, and that is practically a brown ring formation. Okay, so I would just like to list the reagent for brown ring test. Okay, first it is freshly prepared iron 2 sulfates, and then 3 concentrated H2SO4. These are the key reagent for testing that's brown ring formation. Of course, you should know that the anion we are identifying there is nitrate ion. So look at the chemistry of brown ring formation. So first you're going to add H2SO4. Recall that H2SO4 is seen as the king of acid. Most acid, if you are talking about HNO3 acid, you're talking about HCl acid, you're talking about H2SO4 or even ethanoic acid. Okay, among these, all of these are more volatile than this. So this particular acid is going to precipitate at least these two acids from their salts. If you have NaCl plus H2SO4, the reaction is a double decomposition in which the exchange of ion will occur. This will go with this. Now we have Na2SO4. So you add 2 here. So this go with this. What do you have here is 2HCl. So this acid is precipitating this acid from its salt. That is exactly how this acid will precipitate this. This is sodium nitrate. So it precipitates it as HNO3, an oxidizing acid, plus HSO4 minus. Okay. Now, when mainly you add this, you follow it immediately, follow it up. So that's acid. So what you now have in the test tube now after adding this is this nitric acid. So you now add the freshly prepared, okay, iron 2 sulfate, which an additional reaction will occur and then produce this complex compound or mixture. Okay, this has shown that this iron 2 is a reducing agent. So it has reduced this nitrogen here from +5 here to +4, to +2 rather. So this is a typical compound that issue that brown ring formation at the junction of the acid. So this is the chemistry of the reaction. So if you observe in this video, I think in the second stage of this lesson, I'm going to do it. I'm going to place my test tube in this slanting form. This is the portion of the filtrate I already have drained from the filtration process. So this filtrate contains NO3 minus. So I'll pour acid gently here, the conch acid here. It meets here, you start seeing some fume. That fume is NO2. So, but then I will really add upon it the freshly prepared. As soon as I'm adding it, I add a few more acid to it. So I do that sort of you start seeing the brown ring trying to kick out, form at the junction of this and the freshly prepared. So this is what you will see at that particular junction, indicating that NO2 fumes, and then you have now confirmed that the nitrate, the salt, is a nitrate. So this is a theory of what I'm about to do now. So we watch all of this thing now play out practically. So first of all, you see the salt here. This is the salt. Okay, for a very clean, dry test tube. Okay, this is my spatula. This is the salt, the mixture of the two salts. I'll take just very small sample because too much sample spoil results. So to ensure that the results is not that you are going to see any results, just take small sample. I think this is enough. Okay. All right, so this is water. Maybe measure your part of water you want to use. Let's say we measure 8 cm or 10 cm. This is contamination, so you cannot use it. Let me use this drinking water to be sure. So I have to guess the portion of water. I think this is enough. Okay. So you shake to see if there is dissolution. So you see what you have. Some are settling at the bottom, some are up here. Okay, the ones that are going at the bottom is the lead nitrate, as you can see there. The lead nitrate is the one that is going at the bottom. The one that is going up here is the sodium nitrate. So what you do is to separate it with your filter paper. This is filter paper, and how to use filter paper is you take it to this shape and then take it back to this shape, kind of funnel shape. So drive funnel, make it assume the shape of a funnel, and then to the next clean test tube you now decant. Okay. That means that is too much. Take a small sample again. Okay. This is it. While you wait for this one to drain. Okay, I think I'll say filter this again and make sure there is no traces of lead. Okay. Let me use a more clean test tube. Okay. Okay, you can see what we have now. Filtrates. It should be colors. Okay, I think this is enough to run the brown ring tests. The brown ring tests, like I rightly see on the board, you see the conch H2SO4. Be very careful when you are handling it. Just take it side by side. Just deliver it to the filtrate. Observe fume. This fume of NO2. It's at your discretion. You stop. You will still add it again. So next, add your freshly prepared ion 2. Okay, let's see if the ring will appear. Okay, you can see the brown at the junction. You can see the brown ring at the junction of the acid, that's the nitrates here, and then the freshly prepared is somewhere here. So this is the brown ring formation. You see it at the middle. You just see it very thick at the middle of this. You can also see it very clear here. See the brown ring at the junction. If you leave this to stand, it will form a dark ring. Okay, watch the screen so you see the brown ring. Don't agitate it so it doesn't disappear. This is the brown ring form at the junction. Okay, so that is the tests for brown ring tests. So you can pause the video, go back and also watch to see what's really happened. Okay. Okay. So we look for our filtrate immediately. I mean, the filtrate, we have done the filtrates. The ring is still here. So the filtrate is still here, draining. So use a clean test tube. Be very careful when you are carrying out qualitative work in the lab, because any traces of impurity will spoil your results. So this is the sample of the drained residue. Observe it. It is white. Maybe I'll allow it to drain. Okay, well, this one is draining. I can take some from here. A small sample is enough for you. A small sample. Small sample. Okay. So you can just add some little water to. This is the lead carbonate. Okay. The lead carbonate. Okay. I'll look for the acid that will dissolve it. HNO3. See if it dissolves. So you see bubble. See bubble. Let's dissolve the one at the neck. See bubble. See bubble. See bubble. So you see all the whites lead to carbonate had all dissolved. So what we have in here is lead nitrates. This is lead nitrates. Okay. This is lead nitrates. And the lead nitrates, this will be enough for us to run the 3 tests I told you for identifying lead ions. That's the first one that can give us 3 cations in drop. In excess, 2 cations will be left with ammonia. We confirm that zinc is nowhere to be found there. And then the last but not the least will be for confirmation that it is actually lead ion in the mixture. Okay, I think this is the filtrates. So this is the dissolved residue. Okay, I'll take small sample because I'm going to divide it into 3 portions. This is the lead nitrates soluble. Okay, I think this will be enough. So let me take small. Okay, this will be enough. Okay, so let's start with sodium hydroxide. I'll start with drop. Drop wise, drop wise, drop wise, drop wise. So you see white precipitate that is chalky in nature, and then let's see what happened in excess. White chalky, see the video, white chalky precipitate. Let's see what happened in excess of sodium hydroxide. Okay, confirm it before you add. In excess, the whole of the precipitate dissolve. Okay, so this is it. Okay, so I'm going to use the same thing to discard, and then rinse. Let's take the next portion. Take the next portion. So the next portion. The next portion, okay. Okay. Any quantity can serve, just that I want to. Okay, I think it's okay. So to use this for last tests. So with ammonia in drop, and then in excess. Okay, this has opened. Okay. Ammonia drop wise. Okay. Contamination. Let's check this. Maybe not the right reagents. Let's do the last test. Okay. This is supposed to be white. Precipitate. Okay, this is what it is. Okay, see, white precipitates. That is confirming that lead is present. Okay, so this is the second aspect of the video. So the last aspect is the table, how to tabulate all of these things we have just seen in the video. Tabulation of the results. The result is tabulated under the subheading texts, observation and inference. Okay. So look at how it is. Tests, observation, inference. Okay. The first one we did, the state we made C before we put some sample in a boiling or test tube is solid. We added 10 cm Q distilled water. We stir, and then we shake, and then we filter. Okay, what happened? C partly dissolves. This is one point that it does not dissolve, because in the explanation of the sample, when you filter, colorless colorless filtrates and whites residue. Okay, you now see it at the point of filter that I'm putting out this observation. At the point of adding water and stir is when I'm aligning this. The inference will be now, since C is like this, so that means C in aqueous states contains water soluble and water insoluble salts. Okay, when you are done with a particular sample, you underline to show that you are done with that test. The filtrate you obtain here and residue you obtain here, you will be asked to keep those for further use. So let's go to question B and work on this and this, but I'll start with this. Then filtrates. The moment we worked with filtrates plus freshly ion 2 SO4 aqueous plus conc H2 SO4. What do you see? There is what? Brown ring formation at junction of the filtrates. At the junction of the filtrates, see it here. See the filtrate here and the acid. See the brown ring here. See the freshly prepared here. So this is it. Okay, so that means there's a fume of gas. So the fume of NO2, NO3 minus present. Okay. Then that is it. Then for C parts, you work on this. Okay, you work on this. But it will be on this note. The first C you work with is residue from this number, from A above. This is where you got it, plus NaOH. What happened in drops? In drops, you have white chalky precipitates, white chalky precipitates. Then what happened in excess? In excess, precipitates soluble in excess. You have to be very brief and straight to point. So upon this white precipitates, you have calcium, lead, or aluminium present. Upon this excess, you will not have this, you have lead or aluminium present. So with this excess of this, you already know that it is not calcium. So the idea that calcium is there has been settled, so it's not there. Okay, so for CI, because they are going to work on this in 3 other steps. Okay, sorry, first I forgot to say, before you do this, it is very important. So from there, you must first of all dissolve it. So plus dilutes, don't make this kind of mistake in exam, HNO3 aqueous. Okay, Then you now filter. So what you have here is dissolves, then effervescence occurs as you dissolves, colorless, odorless gas turns out to be very straight to point, turns wet litmus paper red, turns lime water. You don't need to ask to perform this test, you must carry it out. Lime water milky. See how brief it is. So over here you have that gas is this gas, CO2. From where? Where does it come from? From CO3 2 minus, or even bicarbonate ion present. Okay, so for CII now, whatever thing you get here, you're going to divide it into portions here. So here we have, like, CI will be like first portion from here, from maybe CI above plus NaOH. This is what happened in drops. Here will now be in excess. So what happened in drops? Under drops, they have whites, chalky, precipitates. In excess, precipitates, soluble in excess. So on these notes, you have here calcium ion, lead, aluminium present. But on these notes, lead or aluminium present. Okay, so that's how it best way to go. Okay, the next one we do here was I to the second portion. So here we have second portion from this same part, from A above plus NaH3. What happened in drops and what happened in XX. So in drop, the same thing that happened here will happen here. So we have white precipitates, chalky precipitates, here precipitates insoluble in XX. Only here is soluble, here is insoluble, so we still have lead 2 or aluminium present. So the last test will be for IV. So what this is going to be third portion from the same A above, okay, from B. So this is going to be B, not from, okay, so from CI above plus HCl plus warm, then cool. Okay, so what do you see? There is what? White precipitates on warming. Let me continue here. Soluble on warming, reappears on cooling. Okay, confirms the presence of lead 2 ion. Lead 2 ion this time it can have what? confirmed. Okay, you can go through the video once again and see that how simple it is to carry out this simple test to identify these ions. Thank you very much for watching. Hey, God.